So there are two charts I'm going to have you write down. The first one is the scenario where we have an observer standing on the side, and whatever object we are observing happens separately from the observer. So we can have a truck traveling. I know this isn't really what any truck looks like, but it's just, you got to make do with quick draws. The truck is traveling in this direction. The ball is traveling in this direction. What it will look like to the observer on the side is that the velocities of both of these objects, the truck and the ball, are added together, right? Because they kind of add on top of each other. The ball was already traveling at the speed of the truck, and you give it more energy. Now, if we throw it off in the opposite direction, it will be like that Mythbusters video where the ball cancels out or loses some of its speed because it was thrown in the opposite direction of the truck, right? So they're in the opposite direction of the truck was traveling this way, they will subtract from each other. Now, this is our treadmill scenario where the treadmill is traveling this way, or it's a boat, or whatever is traveling this way. Whatever on top of the boat or treadmill is traveling in this direction, and it causes a subtraction to occur. So for any of these types of scenarios where objects are on top or started on top somehow, opposite means subtract, and same direction, if you haven't figured it out already, means we add. Remember the Mario video? All of a sudden their speed increased greatly when he was traveling in the same direction as the treadmill, and decreased greatly when he was traveling in the opposite direction. Always in these scenarios is whatever number is bigger will determine the general direction of the object. So with any of the same directions, it's easy enough to see. But like with the lady on the treadmill traveling the wrong way, she was still traveling faster than the treadmill was, so she was still generally moving to the left. But whenever the treadmill was the only thing moving, she was traveling to the right. You could see that in the Mythbusters episode where they are able to actually perfectly cancel them out. So it caused the ball to fall straight down, and the only reason it rolled was, again, because of some of its rotational motion that caused it to move. Okay? So bigger number tells you direction. That's the most important thing and probably where the most errors occur on these problems. Okay, let's move to the other table. Make sure you draw both of these and write them down in your notes. All right. So we're here. We have one car traveling in one direction. We have another car traveling in the opposite direction. The worst cars of all time. Let's say these are future cars, like Elon Musk's really terrible one. So they're traveling in opposite directions, and the observer is actually inside one of these vehicles, okay? To the observer inside the vehicle, it will look like the speeds are adding together because by crossing paths, it will look like the object is going faster. In the second one, if you are traveling in the same direction, right, as two objects, you can even see this whenever you pass another car. It will look like whatever motion is occurring is slower than it actually is. And real quick, I'm going to pause the video. I want you to write down this thing right here. Basically what it's saying is in scenario 2, where the objects are moving in the same direction as the observer, when you think of it as passing another vehicle, and if you were to look in your rear view mirror and you're still going at a higher speed than that person, it will slowly look like that car is traveling backwards compared to you. And what it will look like is it is traveling in a negative direction. Okay? Just kind of like understand that you can have negatives for these numbers even when you're both going the same exact direction because of that weird phenomenon. Okay? I want you to try it just by simply looking outside your window or your rear view mirror when you're driving and you're passing somebody. You'll notice it looks like this car is traveling backwards. It's like they're reversing almost. Not reversing at highway speeds, obviously, but they'll be reversing at a slower speed. Actually, it will be the exact number that they are traveling at. So let's say this is 60 and you're traveling at 65. It will look like they are traveling at -5 miles per hour. Is the same general direction. They're just going slower. The difference causes it to look like them traveling -5 miles per hour backwards. Okay? That's it. Make sure you drew everything, write everything. If you need more help, let me know.